Good afternoon, everyone. Thank you for attending this webinar. My name is Mohammed Munem. I am an AWS Specialist Solutions Architect at Rackspace, and I'm here to present what's considered quite a hot topic, GDPR and its implications for your AWS workloads. Over the next 30 or 40 minutes, I'll go over mainly some of the technical aspects of the technical controls available to AWS customers and how they can be leveraged to better prepare for GDPR. According to this press release from Gartner, by and large, more than 50% of companies affected by the GDPR will not be in full compliance with its requirements. It's a scary thought, and instead of preparing for the worst, I'll give you a rundown of the platform options available on the AWS public cloud that can help you and your teams better prepare for GDPR regulation. GDPR being about citizens' private data, it's important to put it into context and see the kind of major data breaches that have been in the news recently. On the left, you can see a kind of visualization of past data breaches, very significant ones, especially across the Atlantic with Equifax. And on the right-hand side, one that essentially began with announcement that around 500 million users on the Yahoo platform were affected by a data breach around 2013, 2014. It was confirmed in 2016, but as recent as 2017, apparently all 3 billion Yahoo accounts were affected. So data breaches happen across the industry and often do not discriminate between larger and smaller organizations. The problem really is that the detection of these breaches can often take a long time. The average, according to Gartner back in 2016, was around 205 days. This may decrease, but it's a huge number. It means that this data that's being leaked is potentially being sold on, being used for nefarious reasons across the world. So before I start, before I begin an introduction into the topic, let me just manage your expectations in terms of what this webinar is and what it also isn't. So this webinar will provide you an overview of GDPR and its relationship to public cloud workloads, an understanding of the AWS Shared Responsibility model, specifically for security, a look at the security pillar of what's known as the well-architected framework, a more or less prescriptive framework that is often delivered as part of a workshop with customers. Both AWS and partners such as Rackspace have the ability to deliver these workshops, but we'll focus on the security pillar. And an overview of some of the AWS platform tools that may be leveraged to assist you with your compliance requirements for GDPR. The webinar will not provide you a comprehensive history of data protection laws in the EU. I'm no legal expert, and I'm not going to delve into matters which are beyond my remit. Legal advice as well, and also advice around implementing specific policies and processes. And also, I will not generally recommend any third-party products in this webinar. So as you're most probably aware, we have a few days left until GDPR comes into force. 25th of May, around 87 days. It's considered the most comprehensive and progressive piece of data protection legislation in the world, updated to deal with the implications of the digital age. And since the Data Protection Directive, Directive 9546 EC came out, this is the biggest change in European law. According to the International Association of Privacy Professionals, it's a game-changing regulation that affects many US companies' standard privacy and security practices. So this is a view from across the Atlantic. The cybersecurity workforce of today, not just the future, must be prepared to accommodate global privacy standards in their everyday tasks and responsibilities. So it's essential, and around the world, organizations are waking up to the fact that to remain competitive, in fact, to reach out to European consumers, they must take our regulations seriously. So responsibilities under GDPR, I'm just going to read this out verbatim. The protection of the rights and freedoms of natural persons with regard to the processing of personal data require the appropriate technical, and it's my emphasis, technical, and I've highlighted this because my focus is going to be technical, and organizational measures be taken to ensure that the requirements of this regulation are met. In order to be able to demonstrate compliance with this regulation, the controller should adopt internal policies and implement measures which meet, in particular, the principles of data protection by design and data protection by default. So the highlighted and the italicized parts of this quote are what I want to focus on today, both the technical and looking at the architectural principles that involve designing data protection and privacy into all of our workloads. So in terms of the goals of GDPR, it's to enable European citizens to have better control of their personal data. It also unifies disparate privacy laws throughout the EU, and it allows businesses to make most of the opportunities offered by what we consider the digital single market. Of course, it reinforces consumer trust, because if you think about it, where would I rather store my data? With somebody or an organization who's thought about GDPR, who is compliant with GDPR, or an organization who is completely unaware and not prepared for GDPR and know my data will be safe. So in terms of the main points of the GDPR, which will form some of the basis of this presentation, it will make it easier for users to access their own data. There's a concept of data portability for easier transfer between service providers. So a service provider that currently holds your data, they must be willing to provide you that data if you want to go elsewhere in a format that is portable. And there's a clarified right to be forgotten. We've all heard about incidents with famous celebrities, etc., who have invoked the right to be forgotten with organizations like Google. So this will clarify the right to be forgotten, where you can request your data be erased. The right to know when a user's data has been hacked. A one-stop shop with one single supervisory authority. And one of the most important points is that the companies based outside of Europe will have to apply the same rules when offering services in the EU. And data protection safeguards are built into products and services from the earliest stage of development. So this is what I mentioned earlier, data protection by design. When an incident does occur of a data breach, the regulation stipulates that the data processor must report, preferably within 72 hours, unless the breach is unlikely to result in a risk to individuals. So an example of this would be a leak of personal identifiable information, PII data. However, if this data is encrypted and what's leaked is in an encrypted form, then the 72 hours may not be relevant. If it involves a risk to the individual, i.e. the leak of the data causes any danger to the individual, then it must be reported straight away. Processors must notify breaches to controllers, and controllers will notify the relevant authorities. Another aspect, citation 101, I believe, is around transfer of data outside of the union. So With the EU Privacy Shield, it supersedes the Safe Harbor Agreement, and it's adopted by the European Commission in July 2016. It's a framework for transatlantic data flow. AWS customers actually have full control of the movement of their data. So although it's in a public cloud environment, your data, you have control over where it sits in terms of region, and also whether it flows outside of that region or not. So the data controller, the customer, determines where that data resides. AWS produced something called the Data Protection Addendum, and it was approved by the Article 29 Working Party. And to quote the CNPD, by using the data processing addendum together with its annexes, AWS will make sufficient contractual commitments to provide a legal framework to its international data flows in accordance with Article 26 of Directive 9546 EC, which will be superseded and adopted by GDPR. Now, let me talk about the shared responsibility security model. In the cloud, there are certain aspects that you as a customer need to maintain control of and ensure the security of. And there are certain underlying infrastructure components that AWS is going to be managing. So the security of the virtualization layer and the core services are the responsibility of AWS. But you as a customer are responsible for the security and configuration of what you build on top of AWS. In other words, AWS is responsible for security of the cloud, and you as a customer are responsible for security in the cloud, your applications, your data, etc., and how you secure them. However, most importantly, AWS provides a plethora of tools that help you build world-class secure applications on top of AWS services. This is a good illustration of the shared responsibility model, where AWS is responsible for the kind of foundational services, the security of the cloud, compute, storage, database, networking of the underlying infrastructure, including availability zones, regions, and edge locations through services such as CloudFront. And in terms of the customer, as a customer, you're responsible for your content, any type of encryption of that content, whether at rest or in transit, the operating system making sure that they're patched, the network configuration, including firewall configuration. We'll talk about security groups in a few slides. The applications, identity and access management, making sure that you adopt the principle of least privilege when you're developing your identity and access management policies. This illustration explains the shared responsibility model in with regard to GDPR. Again, in GDPR, there are controllers and processors. So in a nutshell, the controllers decide what to do and how to use the customer data or the end user data and the private data. And the processors facilitate that by providing a platform for this data to be consumed and used by the controller. So there is also a concept of shared responsibility when it comes to GDPR. So for example, I'll go through these. Legal compliance is a responsibility of both the controllers and processors. System security and data protection by design, again, both controllers and processors, whereas AWS would have attestations to validate that their infrastructure is secure by third parties and by compliance frameworks. You as a customer, you would adopt a data protection by design kind of principle in your designs. AWS has lots of toolings, as I mentioned earlier, to help you achieve this. Records of processing activities. So both AWS as a processor and you as a controller are responsible for keeping records of all processing activities, especially from a forensic perspective. If an incident does happen, you'll both work together to provide incident management, an appropriate incident management response. Encryption, the platform, certain aspects of the platform will have encryption built in, and it's your responsibility as the customer to leverage this according to your compliance requirements. Managing data subject consent, this is completely the controller's responsibility. This is the AWS customer's responsibility. Managing personal data deletion. So we will talk later about the S3 bucket and how you can have lifecycle policies to eventually remove data from S3 buckets. So this is the responsibility shared between both the controller and the processor. And managing personal data portability. So if your customer requests that you give them an export of all the data that you hold about them, all the private data that you hold about them, all the personal information that you hold about them, you'll need to provide it in a format that is portable. And security of personal data, which is your responsibility as the controller. In terms of your processor, or AWS in this case, this is a snapshot of the compliance frameworks and attestations that AWS has achieved. Several years ago, when we were having similar conversations around the security of public cloud, there used to be concerns around the exact location of AWS data centers, about actually carrying out floor walks, etc. But in recent times, this has all been alleviated, and most customers are completely aware that attestations from these organizations is as good as, if not more representative of compliance than a floor walk could ever achieve. So now I'd like to speak about the well-architected security pillar. I've missed out an ED there, apologies for that. So there are 5 pillars of the well-architected framework: security, reliability, performance, efficiency, cost optimization, and operational excellence. And it's telling that security is the one that's highlighted, and it's also one of the first considerations. So there are pillar-specific design principles, which I'll discuss now. So the principles are as follows: implement a strong identity foundation. We'll talk about the principle of least privilege and how tools like, or platform services such as IAM facilitate this. Enable traceability. We'll look at login in AWS Cloud. Apply security at all layers. So almost adopt a security or defense in depth type approach to security at all layers. Automate security best practices. I've highlighted this and I've underlined this because a lot of security a lot of traditional organizations that do not have much of a footprint in AWS, their security best practices are probably around proactive monitoring by humans. In the AWS cloud, all the services are accessible via API. And this brings in a new era of what some people call DevSecOps, or the ability to automate security best practices. And we'll discuss that later on. Also, protect data in transit and at rest. So we'll talk about encrypting data on things like EBS volumes, and also in transit through platforms like the AWS Certificate Manager. And also how to prepare, design principles cover preparing for security events. So in terms of security in the clouds, there's 5 key areas that the well-architected security pillar covers: identity and access management, detective controls, infrastructure protection, data protection, and incident response. To map these 5 areas against the key services is this illustration. So for identity and access management, you've got the IAM service. You've also got the ability to have multi-factor authentication tokens, both software and hardware. In terms of detective controls, you've got CloudTrail, which logs all API access requests. AWS Config, which will give you an understanding of any config drift historically. Amazon CloudWatch, which will allow you to monitor events. Everything from simple CPU spikes to more custom alerting can be configured. Infrastructure protection, so AWS Amazon VPC, so it's your private segment of the cloud, if you like, which is not accessible by any other customer unless you specifically allow consent to this and enable it through VPC peering, for example. Data protection. So in terms of defense in depth and protecting your environment at every layer. So in terms of public access, one of the first portals through which anyone will access your workloads is through the Elastic Load Balancing services, most probably, unless you have a specific custom requirement for non-AWS based load balancers. You've got the EBS volumes, you've got S3, RDS, and the key management service, which is very important from encrypting your data at rest perspective. Incident response, again, look at IAM, look at the credentials, look at how they were used, and CloudFormation. Quite useful if, for example, you want to, in response to an incident, you want to spin up a new environment. By defining infrastructure as code, you can do that quite easily. You can move a compromised instance from one environment to another very easily in order to carry out further forensics. When partners and AWS themselves sit with customers to discuss aspects of the well-architected framework, there'll be questions that are asked and best practices which are suggested along with the context, etc. And here's an example of the kind of questions you might be asked. And it's quite relevant because it's a question about its an incident response. So let's go through the pillars in a bit more detail and the kind of key services that allow you to configure controls around these pillars. So identity and access management, we want to protect our AWS credentials. I'll talk about the top 10 controls later on as a summary of this webinar. But for the time being, just briefly, you really don't want to be using your root credentials. Every AWS account has root credentials. You really want to lock that away with MFA, in preferably a hardware token somewhere in a safe. And you want to only use IAM credentials. If you're sharing data with, say, third parties, use AWS Secure Token Service, which gives you temporary credentials, which could be configured. Instance profiles, which let you assign privileges to instances rather than hard coding API keys into applications. And in terms of fine-grained authorization, look carefully at the IAM roles and policies. Use a principle of least privilege. I've seen bad practices where when an external audit is happening and the auditor asks for read-only access, some may even give root access to these auditors. You need to really consider giving even auditors the least amount of privileges that they require to carry out their job function. There are policy wizards that will help you do this to make sure that you give fine-grained access control. And also AWS organizations which allow you to look at all of your accounts in a holistic way and apply policies accordingly. In terms of detective controls, capture and analyze logs and integrate auditing controls with notification and workflow. So you've got AWS config rules, you've got the Elasticsearch service, you've got CloudWatch logs, you've got Amazon Inspector, you've got EMR, which allows you to analyze huge amounts of log data, and you've got other services such as S3, etc., which can store your data according to lifecycle policies and also have audit logs associated with them. Every service that you can see has adequate logging facilities so that you can look through them and find out exactly what happened, what's the configuration drift, was it a malicious action, etc. With if you use a platform service like Amazon Inspector, your DevSecOps or DevOps team can use their existing tool sets to hook into Amazon Inspector and find out and respond to issues in the environment. Infrastructure protection, the third pillar. In terms of protecting your perimeter or your network and host level boundaries, you've got VPC security groups. So apart from VPC security groups, which are considered host-based firewalls, you've also got network ACLs. However, network ACLs are not stateful in that you have to define both inbound and outbound rules. And in a lot of cases, in most cases, the security groups will be sufficient for your compliance requirements. You also have Direct Connect, which allows you to connect your on-premises network directly into AWS. And obviously, you've got AWS's VPN service through the VPC VPN gateway, which provides a highly available VPN endpoint for your on-premises or third-party access requirements. From a enforcing service level protection, you've got the AWS Key Management Service, which allows you to either let AWS generate your private keys for you, or you can import your own customer management keys. And alternatively, you've got the cloud HSMs or hardware security modules where you completely control your keys if required. And S3 allows you encryption as well. In terms of system security, configuration maintenance, again, Amazon Inspector makes another appearance, and EC2 Systems Manager, which has a number of tools associated with it, run commands, so you can automate PowerShell scripting, etc. You've got parameter store for storing credentials. You've got patch manager for patching your guest OSs. You've got inventory to give you an asset inventory. In terms of data protection, I'll discuss this in a couple of slides' time. There are some really cool services that have been released. One of them is Macy, which is a platform service that allows you to detect where PII data is. At the moment, it supports the S3 platform, which means that any data on S3, CSVs, text files, including MySQL dumps, etc., it can go through them and identify and classify PII data. There are obviously third-party tools and open source solutions to help with this. And also the key management service is very important here again for encryption purposes. Encryption and tokenization. It's quite a kind of more emerging trend nowadays is to tokenize user data. So this is whereby personal identifiable information is tokenized into either a hash or similar, which can only be understood by the decrypting engine or the platform. So Cloud HSM is where you can also store your tokens securely, and also DynamoDB has similar functionality to store tokens, especially where latency, etc., is a consideration. Sorry about that. So your Cloud HSM, you can actually connect this physical hardware security module directly to your VPC, which is important from a latency perspective. You really don't want your encryption to slow down your applications. Protecting data at rest. So again, both on KMS is mentioned, S3 platform, object storage is mentioned, EBS, your volumes which are attached to your EC2 instances, they can be protected using the KMS service. And Amazon Glacier, which is for long-term archival purposes, and it encrypts data by default. In terms of protecting data in transit, both the classic load balancer and the application load balancer allow SSL offload, and also you can leverage the AWS Certificate Manager service to provide free of charge certificates for your load balancers. Amazon CloudFront also offers encrypted endpoints, and AWS Shield. So AWS Shield has is built into a lot of the platform services, for example, the load balancers, and there are also advanced offerings available from AWS, but essentially it's an anti-DDoS platform. Data backup, replication, and recovery. You can replicate your data across regions, obviously bearing in mind GDPR and the restrictions around GDPR. Bearing in mind the restrictions around GDPR, we're talking about inter-region within the European Union when we're mentioning this, unless there's a specific reason that you can justify for moving it across the Atlantic, for example, where there is something like the relevant frameworks in place. So S3 lifecycle policies and versioning. So you can have processes whereby your data is moved from full redundancy to reduced redundancy to then to Glacier eventually for long-term archival purposes. And EBS snapshot operations. So this is whereby the snapshots, the EBS volumes for your EC2 instances are snapshots as a form of backup. I've just mentioned there that Rackspace has an open source tool available which helps you automate the snapshot-based backups. So you can automate and have a retention period, let's say 35 days, very similar to RDS-based backups that are available within the platform today. In terms of incident response, and this should be number 5, it's number 2, sorry about that. You've got key AWS services, again, look at IAM, CloudFormation, quite useful if you want to recreate the environment and do further testing. EC2 APIs, for example, if you want to block access to particular instances en masse, you can feed them into through your SDKs and make API calls, etc., to ensure that damage is limited, and also step functions that can have logic in terms of an incident management process. So I did mention that there's a cool new service that AWS has released called Macie. And Macie uses machine learning to help identify and protect sensitive data stored in AWS from breaches, data leaks, and unauthorized access. At the moment, the simple storage service, or S3, is the initial data store. And Macie at this time is able to recognize the following PII artifacts: full names, mailing addresses, email addresses, etc. And it takes advantage of CloudTrail and checks continuously for CloudTrail events for put requests in S3 buckets and automatically classifies new objects in almost real time. This is an example of the output by Macy. So you can fine tune it and ask for particular types of data. You can classify PII types and also assign PII priorities against these. In terms of non-S3 based data today and classifying that, instead of recommended any third parties, I'm just highlighting the Gartner Magic Quadrant for data loss prevention platforms. And this will be relevant where you have data in RDS, MongoDB, Microsoft SQL, etc. Guard Duty is also another new platform service which carries out continuous account and network monitoring, also uses machine learning and anomaly detection. It's got very actionable security findings, and it's got zero footprint. No agents are required. No infrastructure is required in your account. It's completely managed and hosted by AWS. Also, it doesn't even require you to turn on your own CloudTrail logs. There's separate streams of logs, etc., which Guard Duty can access. So in terms of some of the things that, some of the threat detection types that Guard Duty covers, from a reconnaissance perspective, you can look at port probes, you can look at brute force attacks. It has a list of, for example, commonly abused source IP addresses from which the attacks appear. You'll look at things like Tor communications. You can find out things like Bitcoin mining. Are your instances being used to mine Bitcoins? You've probably more than aware that there are a lot of websites out there, malicious websites, or even compromised websites where JavaScript has been injected to allow the attacker to mine Bitcoins using the CPU processing power of the end user. So this, the Guard Duty will go in some way towards mitigating that if your web servers are in, for example, AWS. In terms of account compromise, malicious API calls by, for example, bad IP addresses are detected, and certain high volume of describe calls, for example, it may be an audit, but it may be something very malicious like a reconnaissance attack. These things are detected as part of the Guard Duty platform. So what I want to focus on now, by way of summary, is to talk about some of the top 10 controls that you should be considering as an AWS customer in order to help you prepare for GDPR and also to protect your environment from any type of compromise of data and leak of data. So, number one, and I mentioned this earlier, just to emphasize, do not use root credentials, especially for API calls. These are unrestricted. Again, secure with a hardware MFA and store in a safe is a good recommendation. If you need admin privileges, use IAM to create an admin user, maybe assign them to a role, a group, etc. Use the principle of least privilege to assign absolutely the minimum required permissions for a user to carry out their job role. And I mentioned the case of not providing enhanced privileges to, for example, external security auditors. It's ironic, but you might be giving away too much there. MFA and password policies. So the MFA tokens, you've got options of using things like Google Authenticator and also a hardware token. And they can be used with API calls even. Good password policies are a must. And if you have If you have a business technical support agreement with AWS, or business support as it's called, you'll be getting trusted advisor alerts and reports pointing out these deficiencies that you have. Similarly, if you are a customer of Rackspace, for example, you'll get a lot of these security kind of recommendations as part of the service that we offer. Automate these baselines. So, for example, Compass gives you a whole bunch of security best practices and recommendations. Protecting the perimeter. We spoke about the perimeter. Often the perimeter will have a load balancer. If you're architecting with best practice in mind from a security perspective, you will only put in public subnets. What I mean by public subnets are subnets which have direct access to the internet through the internet gateway. And private subnets are subnets where to reach the internet, you have to traverse something called a NAT gateway or equivalent. So with security groups, you are limiting access, both ingress and egress, to absolutely the services that are required. Often due to certain, due to neglect, maybe egress rules are not looked at carefully, but these should be looked at to ensure that services can access only the services that they need access to. Also, the WAF, Amazon WAF, can help you protect against common web exploits, things like SQL injection, etc. And a lot of these services are, I don't want to delve into costs, but these are a nominal cost compared to third-party platforms, and they should be enabled by default for a lot of customers. Secure your AMIs. So point 4, secure your AMIs. If you if you are designing an environment which will host a lot of infrastructure, one of the weak points can potentially be your AMI image. Consider using the Amazon Linux AMI, as that is already hardened. And also consider using the CIS benchmarks for EC2. So these are provided by the Center for Information Internet Security, and there is automation available through an AWS Quick Start, which I'll discuss in the next slide. And also consider using configuration management tools such as Opworks, Chef Puppet, etc., to minimize the number of unique AMIs. So once you've deployed an AMI, configuration management lets you define the applications that live on that AMI, and instead of pre-baking everything into the AMI, which may prove difficult from an update perspective. When you then need to update the AMIs, you may have to deal with 100 AMIs that need updating versus a centralized configuration management platform, which can push out changes or even pull changes from an agent perspective. So the CIS benchmark on AWS is available as a quick start, and it will go through your account, and it has a list of controls that it goes through, and it helps automate some of the controls that you would ordinarily will take you several days, if not weeks, to go through. Number 5, secure your guest OS, especially critical patches as they come, because you could configure, you can protect your perimeter, but if you look at your instances, they may be running an old version of the OS that is not patched, and this provides an attack surface for hackers, both internal and external. And use Systems Manager to automate patch management. Number 6, ensure data at rest and in transit is encrypted. Certificate Manager, for example, uses TLS 1.3 certificates. Do you really need end-to-end transport encryption is one question. If you do, then consider using ACM-based certificates on the application load balancer, and then self-signed certificates within your instances to provide end-to-end encryption, if that is a requirement. That usually ticks the boxes for most compliance frameworks. Use KMS for encryption at rest requirements, and also enable automatic, consider key rotation for customer managed keys. Number 7, monitor unauthorized access. So you can automate your findings from CloudTrail to monitor for unauthorized access. As I said before, all these services have APIs, and you can hook in your third-party vendors, intrusion detection tools, etc. You can also create your own applications and scripts to leverage the data from there to produce a dashboard. You can also look at things like Elasticsearch, Kibana dashboards, etc., to consume the data from your logs to give you a good overview of what is happening in your environments. You can also trigger alerts based on API activity, and SNS can be used for notifications, both email and SMS text message, for example. And when given access to third parties, use a secure token service. It gives you temporary credentials instead of IAM access keys, which have limited lifespan. And one of the things recently in the news and needs to be highlighted is to secure your S3 buckets. AWS gives you a platform to store your objects. Some of these objects you'll need to share publicly if, for example, your S3 bucket is enabled for HTML web hosting. However, if you incorrectly define the permissions or you make it too permissive, you can potentially leak confidential data, and there's been many high-profile cases in the media of that happening. And AWS have recently made the automated AWS Trusted Advisor, specifically the S3 bucket permissions check, available for free. That will alert you if you have very permissive S3 buckets that may contribute to a data leak. Something recently in the news about S3, there's a person that goes by the alias Buck Hacker, and what they figured out is that if they look at a number of DNS subdomains which have been configured with CNAMEs, which point to S3 buckets, some of his reconnaissance came back with these CNAMEs, where they were pointing to an S3 bucket that had previously been configured, but is no longer around. And what this means is that attacker is able to log into AWS, create an S3 bucket matching the bucket name specified in the CNAME record, and the attacker installs malicious scripts, for example, a crypto miner on an S3 bucket enabled for website hosting. And the attacker essentially uses the reputation of the domain name to advertise the subdomain to unsuspecting visitors. So an attacker could take great care to make the subdomain appear to be part of the main domain, and they could even get something like $75 worth of, $150 worth of Google AdWords credit, and maliciously mine Bitcoins or similar cryptocurrencies through user access. And it can also be used to obtain user details through phishing attacks, etc. So something to be careful about. You can obviously use automation here as well, especially if you're hosting your DNS records with the Route 53 platform. Alternatively, at a minimum, you should go through your DNS records and make sure that nothing's pointing towards an unconfigured or non-existent S3 bucket in case somebody effectively hijacks that subdomain through the redirection attack mentioned here. And finally, carry out penetration tests or vulnerability assessments to determine potential attack surfaces. But one important thing to note is that you need to notify AWS in advance of carrying out any vulnerability assessments. And you can ask for specific permission, or you can ask for general permission as well. And So that's it. Thank you very much for listening to this webinar, and I'll open the floor to questions. I can see some in the chat window now. So someone asked a question, is there a checklist available with all things to ensure with having mandatory and optional recommended points? So in terms of GDPR itself, there are organizations such as the CISPE. So this is a consortium of cloud providers, of which AWS is a member, who've created something called a code of conduct, which covers IaaS providers, so infrastructure as a service providers. And they have interpreted the requirements of GDPR from a cloud service provider perspective. And they've it's a voluntary at the moment, but there is scope for this voluntary code being adopted by GDPR in the future. But this effectively gives you assurance that your cloud provider is meeting the regulatory framework when it eventually does get adopted. Question 2 is around which MFA tokens do you support? So I mentioned Google Authenticator. The other one I'm familiar with is Gemalto. I'm not sure what others are supported. I can definitely look into that for you. If you have any other questions, feel free to ask them now. Okay, perfect. I think there may be one more, so I'll just wait for that one. Areas that need to be looked at, etc. Okay, so the question about any tools available that one can run within AWS that will check against all the mentioned points, e.g. a dashboard, traffic light system, etc. So apart from the trusted advisor, Rackspace, for example, for its customers, has something called the Compass platform. And it does hundreds of checks across the account from a best practice perspective. Of those, there are specific security-based ones, which will be modified and adjusted as new compliance frameworks come along. And they'll give you a good understanding of your security posture. However, in terms of exact gap analysis, etc., there are third parties in this space which I'm not familiar with. Another question is around do I need to replace it with an Amazon name? No. The question was around whether an AWS instance using the Ubuntu AMI needs to be replaced with an Amazon AMI. No. But in terms of recommendation, this Ubuntu is supported on the AWS platform. However, in terms of recommendations, consider using the CIS benchmarks to make sure that your operating system is hardened, essentially to ensure that the attack surface is minimized by, for example, stopping services that are not required, etc. Question for Garducci and Macy. Okay, so there's a question. The question is around, should customer, you mentioned the customer should control the data that lies within the EU regions unless justification is given for export outside of EU. Some lawyers consider using AWS in general as exporting, as AWS is a US company. He thought that I'm definitely not a lawyer or legal expert, but in terms of data center locations, for example, AWS has a data center location in Frankfurt, and AWS is also attested by the C5 German compliance framework. So generally speaking, if you pass the German kind of compliance frameworks, you are pretty safe in terms of offering a platform to your customers in Europe. But I shan't comment on anything legal though. Okay, somebody asked a question about guard duty. Is it kind of intrusion detection was a better solution is around in AWS. So intrusion detection, if you're familiar with intrusion detection systems in a typical data center, yep, and I'll close with this question. AWS VPCs don't expose much in terms of layer 2, so you can't have inline devices. So you have options of agent-based intrusion detection systems, but also with Guard Duty, it's a newly released service. It will only evolve with time, and it will get better at detecting intrusion threats, vulnerabilities, etc. But there are many third parties in this space that offer services through the AWS marketplace that you may want to look at. So thank you for that. Thank you all for attending, and thank you all. Hope you enjoyed the session.